Hello, everyone. This is my attempt at a second video regarding the building of a dedicated sound vehicle, bass vehicle. So I discussed my acquisition of the Ford Transit Connect and my intentions. To reiterate, my build goals here are 10 grand or less. To me, that's still a lot of money, but to do a well-rounded, impressive, sufficiently capable, have the electrical infrastructure and enough sound equipment to impress in a car show or a cardio event, I think it's going to be about 10 grand. This journey will determine the validity of that statement. My goal number 2 is 155 dB SPL at 20 hertz. I've already stated the importance of the 20 hertz value. Let me pull up equal loudness contour. Excuse me. My cold is going to ruin this entire video. I'm not going to read all of this. I'm actually just going to pull some images up for you guys to see here. So this is like case study, scientifically determined, like the average human being, we do not hear all sounds or all frequencies at the same amplitude. There is an average that's been done. Let's see here. Which one of these drawings do I like the best? I don't like that one. Maybe I like this one. They're all close enough to the same that it doesn't really matter that much. That one's tiny. Come on now. I tried to script this and organize my thoughts, and my ADHD takes over, and I think it's better for me to just do my best to shoot from the hip. So what we're looking at here is sort of the inverse of the sensitivity of the human hearing on average. What this means is that the human ear on average is, I think we're 1,000 hertz right here, 2,000, 3,000. The human ear is the most sensitive in the 3,000 to 4,000 hertz range. There's a lot of potentially interesting evolutionary aspects to that. The average baby crying frequency falls into that 2,000 to 4,000 hertz range. Interesting fact. We tend to hear 4,000 hertz the most sensitive. And as we decrease in frequency, our sensitivity decreases, and this curve indicates the amplitude required for us to perceive equal loudness. So at the threshold of hearing, we've got to hear 20 hertz at 75 dB SPL in order for it to be perceivable to our hearing, where it only takes, let's see here, sound pressure. Yeah, like the way that sound pressure is measured, what is considered zero, or even, I guess, according to this graph, less than zero, is how sensitive we hear those frequencies. Our hearing decreases in sensitivity the higher the frequency goes. The older we get, the worse that this is. But at increase in amplitude, the curve changes a little bit, but it's still not flat. This is a point of contention I've had with the audio scene forever. High-end home theater, pro audio, master recordings, everybody has the standard of industry to measure to flat, which doesn't make sense to me. And I think the idea is that if the recording studio measures a sound system flat, and then they master it so that it sounds good to the ear, and then you have a home theater, headphones, car audio, pro audio application that is tuned to flat. When you play back the recording, it is mastered to sound good. And I think that that's why that standard of industry exists. For some reason, I'm inclined to say it would be better to tune a system to match the equal loudness contour. I mean, I guess all of that's sort of up in the air. My experience is that a system that is actually tuned flat really doesn't sound good. Purists. So something that's really important to consider is that in the equation of sound, you've got the sound equipment, the environment you're in, and your ears. The problem with our ears is that they change from day to day, they change with age, and they are like, our hearing is tied directly to our emotional circuitry. And that correlates to genre of music preference. It's the same way that everybody has different music preferences, different genre preferences. Our hearing preferences are unique from human to human. It's different. You get a group of people together at a heavy metal concert. You've like minds. Everybody likes the same thing. Cardio events or competitions, everybody there likes insane amounts of bass. Well, I'm tangenting, but this is a very critical piece of information to understand. The reason I want the peak output of my car audio build is at 20 hertz is because it's going to create the most pleasant listening experience based on the equal loudness contour that is essentially a representation of how our ears work. So I want the loudest frequencies to be the lowest, and then I'd like the sound system to have a nice, beautiful taper rolling into the mid-range and the high frequencies so that it's a really pleasant acoustical experience. The windiest builds happen at the lowest frequencies, and I'd like to have a very pleasant, very intense, but very low frequency acoustical experience. I'm not building this dedicated for cardio competition. I haven't read any of the rules. I don't frankly care about rules. If I get this build built, yes, I have every intention of metering it, competing in whatever categories I can, getting as much exposure with this build as possible. But I'm not building it for the sole purpose of pegging a meter at a specific set of rules. I want this to be a fun vehicle to share with people that is well-rounded and exciting. That's my goal. Okay, so this, in my opinion, explains to some degree why the 20 hertz frequency. Let's talk about Hofmann's iron law a little bit. This is the next thing that I think is the most important to consider when it comes to a build, any car, any audio application. The fundamental thing you have to understand is Hofmann's iron law. I intend to do many videos elaborating in detail regarding Hofmann's iron law, but a fundamental piece of information that's needed before I can move forward designing and building a sound system is an understanding of Hofmann's iron law. My intention with these videos is to sort of take you through as many of the basic principles and building blocks to build a foundation that we can use to make sound decisions and choices when it comes to a build. I'm not going to read this. I've got this up on the screen. You guys can research it. Something that I think is interesting, if we pull YouTube, I believe there's only 5 or 6 videos out right now. If you just do a search, what is this not working? This is a short. This guy's channel is pretty well reputable. He's got a dedicated video referring to Hofmann's iron law. We've got 2, 3, 4. I'm not a huge fan of this gentleman, but the fact that he makes a big deal about Hoffman's iron law is significant to me. Um, Jacob Fuller, absolute legend in the industry, has a dedicated video, relatively recent, but he's got lots of forum presence where he's presented a lot of this information. But, I'm a dwarf compared to this gentleman. Let's see here. Maybe all of these videos talk about Hofmann's iron law, but only the first handful actually specifically reference it in the video. 1, 2, 3, 4, 5, 7 videos. That's a big deal to me. There should be far more. Anybody who claims to have sufficient wisdom to post about car audio should have some content on Hofmann's iron law. It is an absolute fundamental principle to understand, and with that understanding, it solves a lot of problems. I'll build speaker boxes for people all the time, or I get lots of requests and discussions regarding it. And so often people say, "Oh man, I just want it to hit. I just need you to help build me a box that'll hit. I just want it to slam. I just want it to be loud." And it's like, it's so much more complicated than that. Loud at what frequency? What frequency do you want to be able to play? It's a little bit more complicated than just hit. Hofmann's iron law, it's sort of a law of physics, and basically what it means is that the lower the frequency, the harder it is to reproduce. Bottom line, it requires more power, more cone displacement, more drivers, and the higher the frequency, the easier it is to generate. It's just a law of physics. Why does it take a 15-inch subwoofer in your trunk to make good bass, but all you need is 2 tiny 1-inch tweeters to play from 2500 hertz all the way out to 20K? That's a huge spread of frequencies, and 2 little 1-inch tweeters often is sufficient, where if you just want to play from 20 hertz to 40 hertz, you need an 18-inch sub, you need 412s, you need a lot. This is Hofmann's iron law. I will get into that in more detail later, but that is a fundamental thing that I want to bring up. For those of you who don't know about it and you're trying to go on this journey with me, or be better, learn more so that you can do better builds in the future, definitely seek this stuff out. There's a guy, this gentleman right here. He actually has a very good video. This might even be the video itself. Check this guy's video out. DIY audio guy. He goes into depth. He goes into the history. I'm not going to make a video as good as him. Go check out his video and learn about Hofmann's iron law. It's a fundamental principle that I spent the first 10 or 15 years doing car audio and had no understanding of it. And it's a shame. It's the first thing you should learn. Okay, so moving on. We've talked about equal loudness contour. We talked about Hofmann's iron law. This question pops up a lot. How do we determine the best subwoofer for the application? What metric do we use? What specification determines the best subwoofer? It is the standard of industry to talk in wattage. Everything is rated in watts. No matter where you go, everything is wattage. And it's super frustrating once you start really learning a thing or two about sound. Wattage has absolutely no direct connection to how good anything sounds, how loud it is, how it performs. It's an important spec, but it just doesn't tell any realistic component of the story. wattage is simply a multiplication of a voltage and a current. Wattage tells you how much power is consumed. And the sad reality is that you could have a 10,000 watt sound system that is actually a heater that plays music. And you could have 80% of that electrical energy being generating heat, a very inefficient heater, likely, and only 20% of that is generating sound. So just to say you have a 100,000 watt sound system doesn't mean anything. There's no wattage value that directly translates to an SPL value. Now, there are rules of thumb. There are averages, and cardio competitions have been going on long enough that there's kind of an average. A certain amount of wattage does typically mean a certain SPL, but that's really not just the end-all be-all solution. So for me to so within the goals that I have in mind, $10,000 or less, that means that I have a budget that is fairly tight. That means that I can only have a certain amount of electrical energy. I can only afford a certain battery bank and a certain amount of amplification. And therefore I have a wattage limit. So yeah, in theory, I could say, well, let's just say 10,000 watts is my limit. And I could just find the most subwoofer that I can get that's 10,000 watts rated. Here's, where's a good example? Here's an example of a subwoofer that is very high power rated. This is made by Eminence. It's an American company, most known for pro audio, DIY pro audio. I've had Eminence equipment before. This is a 21-inch professional grade PA speaker. Like, this is a monster. It really is. 21-inch diameter, neodymium. This thing is epic. Well, they've got this thing rated to handle 5,000 watts. It is a 21-inch driver. Like, this thing is no joke. It's monstrous. They boast 21 millimeters of excursion, which is a lot for a PA driver, but 5,000 watts. Well, so if I was to set myself up for a 10,000 watt cardio build, I could afford to run 2 of these, which would consume my entire 10,000 watts that I predict is available to me. I've got an AI app up here. Let's pose a question. Let me see here. How do I do this? Sorry, guys. I'm shooting from the hip. We've got this much cone area. It didn't do what I wanted. Don't know why it's not doing. Okay, that's not how that works. With 21 mm X max, how much VD? I love my app. Okay, excuse me. I'm jumping ahead of myself. By giving us this example here. Maybe not. Maybe I can bring it full circle. SD, let's go here. Bear with me, guys. This is good content. I'm just scatterbrained about it. When it comes to the small parameters of a driver, yes, there is a wattage specification that is given, but there are tons of other parameters that are involved in the small parameters, and they matter, and I'd like to get into them. And the first thing I'll admit is I'm not an expert. Like, when I watch a Jacob Fuller video and he talk about their engineering design process when they design their subs, it's amazing. I don't have that kind of an understanding. And my understanding is rudimentary enough that I often have to come over here and get a definition of what the parameters mean. So SD is a Thiel small parameter specifically referencing the piston area, the surface area of the cone of the driver. Like, how much surface area do you have? VD is a multiplication of the excursion and the cone area, and you get a total displacement. VD is the diaphragm piston displacement volume at Xmax. This, in my opinion, is a very critical value specification to have, which it's not talked about. It's not posted anywhere. None of the websites, none of the companies are talking about how much VD their drivers have. When you talk about engines, we talk about dirt bikes or quads or four-wheelers or motorcycles, everything is in direct reference to the engine displacement. The entire motorcycle, dirt bike, like sport utility vehicle, 100% of the time, right on the side of the vehicle, how big is the engine? How much displacement does that engine have? It is a critical component. And it is just as critical in the audio realm. Like, how much displacement? How much engine size? How much subwoofer size? Everybody cares about the diameter of the driver, but what's the actual displacement? Spoiler, I am going to make the claim that this might be the most critical specification to look at when you guys go, when anyone goes, when I go to design a build. The more VD, the more displacement, the more ability you have to excite the air, to pressurize the air, to build sound pressure, to be loud. This does not have any direct bearing on wattage. Wattage still matters, but it's not the end-all be-all solution. So here's an example. I'm going to try to jump forward a little bit, and then we'll back up and cover the specifications in a little bit more detail. So with my AI app, this subwoofer, this 21-inch monster driver, way out of my budget. I mean, I could maybe build a sound system with one of these, but just for the sake of the 5,000 watt rating, we're going to run two of these things. And so VD is, for one driver, the VD, the absolute displacement potential of this driver is 3,448.2 cubic centimeters. And at the moment, I'm not that worried about the power handling. That's how much air this thing can move. If we pull up a different subwoofer, this one's a little bit more affordable. Let's see, this is about $350. It's an 18-inch. I am biased towards this, and we'll get to that. What did I do with my mouse? There we go. We'll get to that in a minute. But let's look at the specs here. This driver is capable of 28 millimeters of one-way excursion. So we've got 7 millimeters more excursion potential. And we've got a starting SD of 1184, which is a very common 18-inch SD. So let's put in here, we should just be able to scroll up. Let's go with 28 mm max, how much VD? Okay. We scroll back up here. A single driver has 3,448 Okay, let's do this. 3448.2 times 2, because I can afford to run 2 of these for a 10,000 watt rating. And we've got 6,896 cubic centimeters of displacement. Now, if we go down here to this driver, 3315, my dyslexia is going to ruin all of this. For the cost, oh my gosh, what is wrong with my mouse? My operator error. For the cost of this guy, we can run 4 of these things for about $1,400. So we can run 4 of these drivers for the cost of 1 of these, roughly, give or take $200. If I multiply this by 4, I now have an absolute maximum displacement with that 18-inch sub, this guy, of 13,268. If I go here, that is over double. For half the cost, I have the ability to do double the absolute displacement. And let's look at the wattage rating. This driver is rated at 1,200 watts RMS. So 1,200 times 4, just based off the base specifications, I only need half the electrical energy that I would need with these dual 21-inch drivers. So how on earth can this driver be rated at 5,000 watts a piece and this guy over here be rated at 1,200? Let's talk about that a little bit. So, trying to bring this back to full circle. This is an example that I presented. 2 21-inch subs, 10,000 watt of rated power versus 4 18s, half the rated power, twice the max displacement capability. How does that add up? How does that work? And how does that apply in the real world? I'm not worried about this video getting long because I really think that this content is absolute gold and it's missing in the industry. And if people understand it, nobody that I've discovered, nobody's been able to identify it. Any of these leading video makers have not covered this way. So despite the low quality, I think that this is genius content and I'm excited to share it. So let's look at another subwoofer really quick. I've got this guy pulled up. I don't mean to pick on Massive Audio. I just was trying to find a very high power handling subwoofer. This guy is claimed rated at 8,000 watts of RMS power. It's an 18-inch sub, and this thing's an absolute monster. They boast 165 pounds of dry weight, like curb weight. Like your enclosure definitely has to be robust in order to house that. Interesting thing, they do not post their Thiel small parameters on their website, and if they're available, I haven't hardly been able to find them. I did already search this spec. Let's see here. I tried to get AI to help me identify what the VD of one of those drivers is, despite being rated at 8,000 watts. And on their website, they specifically say two-way. Where's it at? Two-way X-Max, 48 millimeters. I almost think that this is an intentional trick. They want you to think that this thing's got 48 millimeters of X-Max when I think in reality it's only 24 millimeters of X max. I just plugged in what is the VD of that specific driver to my AI app, and it immediately said 2A typically means peak to peak, meaning that this driver likely has 24 millimeters of usable X max. And look, fair enough. I haven't discussed mech peak excursion before mechanical damage versus like your X max with a BL rating of 70% or higher. I think that's the way to talk about it. That's an important factor, and I don't have all the information needed, and I can't necessarily speak up on it. It's actually even harder information to find. As hard as it is to get the X max, X mech is a harder spec to find. It's available when it comes down to modeling software. It's a spec that's talked about. Maximum mechanical excursion one way from rest. If that's sufficiently high, and you have drivers that are capable of 60 millimeters of X mech, those have do have potential to be loud as a result. So that's just as important as the VD that I'm referring to here for displacement, because if you can, despite the inefficiency increase by being out of the magnetic gap, if you still can, displace air, then you can be louder. But just because I'm not an expert at all these things, I'm going to keep it to normalized X max, likely clippable, verifiable, 24 millimeters for this 8,000 watt driver here. Back to this. What does that come out to? They're stating that this driver is around, like, even my AI app couldn't find those small parameters on this, but this basically falls in the same SD as this budget subwoofer, and it has less X max than that budget subwoofer. Do they have a price tag on this guy? Guaranteed $2,500. So this single sub costs as much as two of these 21-inch subs, and the VD of this driver is equal to or slightly less than the VD of one of these, which is basically 3,400 cubic centimeters. So two of these for the same cost has double the displacement potential as this driver here, and four of these has double. So four of these has 4 times the displacement potential of this driver at half the cost. Okay, so I'm harping on displacement, and I'm sort of beating up the idea that wattage matters. Let's talk about where wattage actually matters. Let's tangent again, and let's talk about something like Q factor. So if you were to build an infinite baffle mount, just an endless wall, and you put a subwoofer in it so that you isolate the front cone surface area from the rear so that they don't cancel each other out. No essential enclosure. It doesn't take a lot of electrical energy to drive a subwoofer driver, a loudspeaker driver, to maximum X max or max displacement, because there's no acoustical load. If you start to enclose a driver, you start to decrease the available volume. You start to create an air spring effect. And without me reading this, Q factor has to do with that air spring effect. The smaller an enclosure is, the greater the spring effect, and it affects the performance of a driver. Your output increases and your low frequency extension decreases. I'm not going to read this. You guys can look up Q factor, But this is essentially what starts to come into play. So why on earth would anybody design an 8,000 watt subwoofer if I've already specified that there are other options that are actually capable of more displacement and therefore being louder? Why would you ever do that? So this is back to Hofmann's iron law. This is why it matters. Hofmann's iron law states that there are three main factors when it comes to loudspeaker design: low frequency extension, efficiency, and size. Is that right? Those three? Is that how it goes? And the way the rule goes is you pick two and the third will be an opposite, right? So if you want it to be very efficient and very low frequency, it's not going to be small. There's no way you can have it small. If you want small and low frequency, it's not going to be efficient. If you want it efficient and small, it's not going to have low frequency extension. That's just the law of physics. What does the efficiency part come in? Right here. In order for me to displace all the potential volume that these drivers can displace, because they're low power relative to these other drivers, this is going to require a larger enclosure, a decrease in the air spring so that it has the ability to excite itself. So this is more efficient, but in order to be efficient and low, the enclosure cannot be small. So in order to overcome that, you need higher power drivers. So you have to actually overcome the fact that we're not efficient anymore. So this guy right here, you can probably pack 4 of these, or 8. Let's just say you can pack 8 of these guys in the same volume as 4 of these guys. And if you supply as much power as they are rated to handle, these guys will overcome that smaller enclosure volume, be able to displace to their maximum potential, and 8 of these in the same enclosure space as 4 of these is going to be twice as much displacement, and therefore 6 dB louder or more as a direct result. So why does this driver exist? Why is the SPL car audio community, why is Sundown make absolutely insane monster subwoofers? It's because that's what it takes to overcome Hofmann's iron law. How does this apply to you and I? Here's what's important. If you're still with me in this video, if you're still even moderately entertained, I am unbearably grateful. And hopefully this is worth your time. It is not optimum to just source the highest watt driver you can. When it comes to designing a subwoofer enclosure, you've got to make parameters meet. How much volume do you have available? How much electrical energy do you have available? And then we've got to identify a driver that we can excite to its maximum displacement at that volume with that electrical power. And when you get it all right, you will be outputting the most clean power you can. The driver will be displacing peak displacement before mechanical or electrical failure, before thermal meltdown, and you have the loudest sound system that you're capable of. Just calculating wattage does not tell the whole story. Because again, if I put 4 of these in the same enclosure as 4 of these, and I only put 5,000 watts to them, this is going to absolutely eat the lunch of these. Or it'll be the same, roughly the same. Because this driver is likely to reach peak excursion in that larger enclosure at the same time this one is. Very similar to it. So you might be able to get the same loudness of this driver as this one with the same power, same 4,000 or 5,000 watts. It just becomes a waste. We've spent way more money than is necessary. These type of drivers become valuable and useful. So in SPL competitions, And if you go to these car meets or if you're a builder yourself, these guys are doing 4th order, 6th order enclosures, and they're packing 812s, 818s, 615s. They're packing tons of driver into a relatively small enclosure. And then they're packing tens of thousands of watts of electrical energy to overcome the spring load effect on a small enclosure, and they're able to get insane SPL out of them. Well, if you're in SPL competition, if your goal is to be as loud as possible, then the highest power rating driver you can afford, the most of them in the smallest space, or pack as many into the limited space you have, and therefore, you end up capable of higher SPL. So let's just say this build I'm going to do with this Ford vehicle, let's say there was no budget, 100 grand, just stupid amounts of money. If the money was no budget, I could probably pack 8 of these things into that vehicle and buy insane amplifiers, insane battery bank, and I could probably power them, and I could probably do 165, 170 dB, maybe. But back to the goal here, a $10,000 build, I do not have the budget for this type of a thing. What I have to do to get loud is compromise and find a more efficient system. So how do I close this video out? When it comes to designing the enclosure and picking the right subwoofer driver configuration for this build, and how it matters to you guys when you go to if you buy a vehicle and you start mapping out, is it in your trunk, is it in your back seat, under the seat, you can do a blow through, what's your build. Once you determine the amount of available volume you have, you got to determine the amount of electrical energy you're going to have available. And I understand that not everybody is going to spend the time to get good at modeling software, but even if you have somebody design the enclosure for you, if they know what they're doing, they are going to take the maximum volume of enclosure you have available, they're going to take the amount of electrical energy you have available, and they're going to configure a subwoofer system, whether it's a bunch of 6.5s, 1 6.5, 2 8s, a 10, 2 12s, 4 12s, 4 18s, whatever that ends up being, however much cone displacement, whatever much VD they can pack into that space, so that at max electrical power output, before clipping, before overheating, before electrical issues, you are driving your subwoofers to their maximum displacement, and the enclosure volume is matched. Back to this. The enclosure volume, the smaller the enclosure, the more springy, the harder it is to excite your drivers, but the more efficient, the more power you generate. So you got to figure out what your low frequency extension is. So so I'm scatterbrained. This is, I guarantee, needs to be a follow-up video just dedicated to Hofmann's iron law. And I can generate some information. I can plot a bunch of different enclosure configurations, and I can demonstrate exactly how Hofmann's iron law affects the situation. But for this video, if you want to play to 20 hertz, but you are only going to put a subwoofer under the seat of your truck, you're just not going to be loud, because it just takes so much cone displacement. It just takes so much volume, so much energy to generate low frequencies that you're not going to be loud. And if you want to be loud with a single 8-inch driver, it's just not going to play low frequency. Like, that's just the law of physics. I'll get into that. I'll organize this better. I'll build some enclosure configurations, and we'll demonstrate the efficiencies at different frequency ranges. But the thing that I want to emphasize, that's going to, I don't know about upset the community, but I'm definitely trying to throw a wrench into the works here, is right in the face of everybody who boasts giant wattage numbers. And I'm not hating on massive, but this does not mean anything in an infinite baffle situation relative to another driver with the same displacement potential. This only matters when you don't have enough volume potential to achieve your goals. If you have the electrical potential, or you can afford to buy the electrical to overcome a lack of internal enclosure volume, then this starts to make sense. Excuse me. I apologize. Wattage means nothing unless you don't have enough volume to achieve your goals. Which, fair enough, that's 99% of the time, that's the issue. Car audio scene, everybody's trying to be as loud as they possibly can. And so you do end up packing the most amount of drivers you can in the smallest space possible. And that's where this works. My build, wattage is not important to me. Bottom line, I plan to have a 10,000 watt amp ran at a high impedance for a total output of somewhere between 5,000 and 6,000 watts of actual electrical energy to something akin to 4 of these babies in an enclosure that is capable of letting them displace all of the potential volume they can at an electrical level that they can sustain, right? At 1,200 watts, these things should be thermally capable of absorbing or dissipating the heat that is generated as a direct result of that. And then if I get the enclosure size right, at peak output, low frequency, this thing will be at peak excursion, and it'll be as loud as it can be, and everything will be in sync, in copacetic configuration. Yeah, I admit I'm biased, and this is going to likely be what we use in the build, and I'll talk about that in a later video. Recap, I know this is a long video, I know I'm long-winded. The headway I think we've made on this video is that as we progress along in this build, I am going to try and find the maximum amount of VD that I can fit in my available space. So what I said was I have 42 inches of width, 48 inches of height, and about 48 inches of depth for the enclosure. That is the space I intend to utilize. And now it's a matter of figuring out what driver configuration, a bunch of 8s, 124-inch sub, what configuration gets us the highest amount of VD that we're going to be able to access with the volume of air we have and the electrical energy that I expect to have. That is the next goal. So I guess for another video, what you can expect soon or upcoming is that I will have modeled a handful of different things, and I'd like to be able to compare how each of those performs and what ultimately is what leads to my decision making on what I think will be the most effective to achieve our goals here. Okay, so if you're still here, I'm so grateful. I hope this content makes sense. If this is any kind of successful, comment if I missed something. If you know I'm wrong about something, don't just be a hater. Show me and ultimately everybody else what I said was wrong, where the correct information is, or how I misinterpret something. Links to valuable videos. Let's give credit where it's due. Whoever has the right answers, that's the goal. You can troll me, it's fine. Make fun of the way I talk, make fun of how scatterbrained I am. If it's in good fun, if everyone gets a laugh, bring it on. I'm all for it. I think I know what I'm talking about, which means I know I don't know everything, and I'm going to make mistakes, especially in a video format. If I'm trying to shoot from the hip and articulate this information, it's going to be rough. I'm hoping that I can do it poorly at the start and get better at this, and by the end I hope to be generating high quality content that the entire audio community can benefit from. it would be cool to be a valuable resource in this realm, in this industry, in this scene. What else? What else? Yeah, if you'll ask me questions, then I can make dedicated videos to trying to solve those problems, answer those questions. And if you have a question I don't have an answer for, I guess it means I get to do some research and see what we can come up with. So I appreciate the time you spent listening, and I hope that we can make a good thing out of this moving forward. So signing off for now.